So last time we have seen how to apply the formula for cos A plus B, sin A plus B, tan A plus B. We have seen some problems on it also, right? We'll continue that. So problem from exercise now. So show that in trigonometry most of the problems are like show that sine of n plus 1 times A into sine of n plus 2 times A plus we write here plus cos of n plus 1 times A into cos of n plus 2 times A is equal to cos A. See, these problems look very complicated actually, right? But note that in the mathematics, if the problems look like as a very complicated, it will be very easy. Only have to think a little bit. Such problems are very easy actually. So we'll take LHS now and we'll put the RHS. Okay, solution LHS is equal to. Now see, the first term contain the product of 2 sine, second term is contain the product of 2 cos, right? So see the angles whether they are same now, right? If the angles are same, then we can apply the formula for to cos A are together. That means it is what? Cos A minus B, because sine, middle sign is plus now, right? So if 2 cos are there and 2 sin are there, right? When we can apply this formula? If the angles of the sine and cosines are same. If the angles are different, then we cannot apply the formula for cos A minus B, right? Now here see the angle of the first angle is somewhere here, what? It may be here, doesn't matter, right? But you should get some sign of angle of sine of is same now. So angle of sine and cos are same. Here also the angle of sine and cos are same. That means what? Your cos A minus B is applicable here now. So what is your A now? Your A is this now. This is what? N plus 2, right? So we'll take N plus 2. This is A. For cos, no matter this, you can take any A minus B or B minus A. Formula for cos A minus B and cos of B minus A are same, because cos of minus theta is cos theta. Like you can take any A and you can take any B. No matter. You can write this. You can take this A as also. For cos, no problem. But for sine, A minus B is not same as B minus A. For sine, you have to take care of the only the minus sign, right? Here also you can see, you can take this is what? Any A, any B. No problem for this one. You can subtract any angle from any, right? So once we get some cos of minus theta, you get, you will write this as cos theta, right? So no problem for here. What? We will take cos of. You can choose any A now. We will take first angle as A and second angle as a B. No problem for cos. So n plus 1 times A minus n plus 2 times A, right? So now this is n plus 1 and this is n plus 2. So 1 is greater here, right? So difference will be what? Only A. So minus A difference will be, because n plus 2 is greater. So it will be minus A only. So this is what then? Cos of minus A. But cos of minus theta is same as cos theta. So no problem, cos A. So what do you want? What is your RHS? Your RHS is cos A. So this is RHS. See, it is very simple. Problem was actually complicated, but what formula for cos A minus B becomes, the problem becomes simple. Only you have to think a little bit. Okay. So now we do this second. Prove that. Root 2 cos of pi by 4 minus A is equal to cos A plus sin A. Now remember this as a formula. Remember this as a formula for cos A plus sin A and cos A minus sin A also. If you take here plus sin, you get cos A minus sin A. So it is better to take the LHS now. So take LHS. So this is root 2 cos of pi by 4 minus A. Right? Now you have the formula. This is what? This is of the form A minus B. Apply the formula cos A minus B. You will get the result. So root 2 is here. Now see, you have to write in the bracket because in the formula form there are two terms. So you have to write this formula in the bracket now, right? Because what if you bracket is not there, then root 2 will be multiplied only for the first term. Second term will be as it is then, right? So you have to take the care of this root 2 also. You have to multiply to both the terms. So we write that formula in the bracket. This is what cos pi by 4 cos A plus sin pi by 4 sin A. Okay, so this is what root 2 cos pi by 4 is 1 by root 2. This is cos A plus sin pi by 4 is 1 by root 2 sin A. So root 2 get cancelled, then this is what cos A plus sin A. Remember this as a formula because what cos A plus sin A, this is the two terms and this is the formula. This contains a single term. So that means what, if your denominator is somewhere cos A plus sin A, if you want to make a denominator as a single term, right, because you cannot divide by separately cos and sin if it is at the denominator, right? For denominator we need a single term. So remember this cos A plus sin A as root 2 into this, right? So if here plus sign, what happened then? If here plus sign, then what happened? This will be the minus now, right? So that means what? Okay. So this is your RHS, right? We will write the note. We will write the note. Root 2 cos of 5 by 4 plus A is equal to cos A minus sin A, cos A minus sin A. Cos A minus sin. So remember this as a formula. So this is what? Verify. Verify, right? So verify means what? Do in the rough work, right? So you can verify this by using the same thing now. Okay. Now next, prove that cos x minus y upon cos of x plus y is equal to cot x cot y plus 1 upon cot x cot y minus 1. Okay. So we'll do LHS. We'll take LHS. Right. Actually, from RHS, this is also very easy. From RHS also, this problem is very easy. Right. So, but we'll take the LHS now. We'll take the LHS. So LHS. So try for RHS also. Try for the reverse order also, right? So that what your idea of the trigonometry becomes very clear, right? Try for all the try for that only. RHS to LHS and LHS to RHS also. So this is what cos of x minus y upon cos of x plus y. Now see, this is of the form cos of a minus b. This is a cos of a plus b. Apply your formula. Now, so first apply this one. Cos x cos y plus sin x sin y upon cos x cos y minus sin x sin y. Now look at your RHS now, right? So for RHS you want here 1, here also 1. So that means for this term you don't want. So what we will do? Divide to each term by sin x, sin y, sin x, sin y. All the terms of the numerator and denominator. Now see, you will get here the cos x upon sin x will be your cot x. Cos y upon sin y will be your cot y. So what we will do? We will divide to each term of the numerator and denominator by sin x, sin y. Right? It is not affected to the ratio now because we are dividing to all the terms of numerator and denominator. Right? So this is what cos x cos y upon sin x sin y upon sin x sin y plus sin x sin y upon sin x sin y. No need to write actually here, just write directly 1. So cos x cos y upon sin x sin y minus sin x sin y upon sin x sin y. Now this become 1. So this is equal to what then? This will what? Cos x upon sin x. You can separate this. You can write as the product of two terms. So this is cot x, cot y plus 1 upon cot x, cot y minus 1 cot y, cot x, cot y minus 1. Now when we are solving the competitive exam, remember this as also a formula, right? If somewhere you get cot x, cot y, right? So remember this is what? Cos of x minus y upon, so upward is what? Plus. You may write this is what? Cos of x plus y upon x minus y, then this what? Minus will be interchange. So remember this as the formula now. Okay. So we take the next one. Cos x plus y into cos of x minus y is equal to cos square y minus cos square y minus sin square x. Cos square y minus sin square x. Now see, angles are different now. So this is what? That means these two terms will become a single term, right? So we'll take LHS and we'll prove the RHS, right? So try for also from RHS to LHS. Try for this. Okay. Okay. So we'll do this one. Take LHS. So LHS is equal to cos of x plus y, cos of x minus y. We'll write in bracket. You will write both the formula in the square bracket. So cos x cos y is what? Cos x cos y minus sin x sin y into cos x cos y. So this is what? Cos x cos y plus sin x sin y. Right? Okay. Now this is a minus b, a plus b. So this will what then? Cos square x cos square y minus sin square x sin square y. Now look at your RHS now. Your RHS, you need cos square y. So that means you don't need sin square y. That means what? Replace sin square y now. Now for what? You need sin square x. That means you don't need the cos square x. Replace cos square in terms of sin square. Now replace your sin square y in terms of cos square y now. Right? Just write down this. This is what? 1 minus sin square x cos square y. Now here what? Sin square x. You don't want sin square y. So 1 minus cos square y. You have to take the help of the RHS also. Right? And just simplify this now. So what we get there? This is cos square y minus sin square x cos square y minus sin square x plus sin square x cos square y. Whether these are same? Yes, they are the same. Get cancelled. Right? So we get cos square y minus sin square x. This term get cancelled. Now just underline that for the same term. Right? Don't take the tick now here. Right? So draw the underline for the similar term instead of cancelling that. Right? If there are more than two terms, just that write a double underline for the same. Right? A triple underline for the same. If there are more than terms, then use the underline. Okay, so this will be your RHS. This will be your RHS. That means our problem is over. So here what? The problem is what? How to start only. This problem is what? How to start. Right? If you understand is how to start, then all the trigonometry problems are very easy. Okay. Now next, tan 5a minus tan 3a, so that upon tan 5a plus tan 3a is equal to sin twice a upon sin 8a. upon sin 8a. Okay, we'll solve this. We'll take LHS. Right? Take LHS. Take LHS. See what happened if you take the LHS now. Now here what? We don't know the formula for tan A minus tan B right now. Right? We don't know. So what we do? We'll express this in terms of sine and cos now. Right? We'll express that tan in terms of sine and cos. See what happened here. Sine 5a upon cos 5a minus sine 3a upon cos 3a. Okay. Now see, denominator is also contain 5 and 3a. Right? So there are chances, there are more chances to cancel the denominator of both the numerator and denominator now. So sine 5a upon cos 5a plus sine 3a upon cos 3a. Right? So we'll do the addition now. See, both the denominators are different now. So that means what? By with the help of cross multiplication. Now see, now denominator will be what? Now here we get a product now. Here also we get a product because there are two terms. So both the denominators will be same. Right? So we are not writing the denominators of the numerator and denominator. Just we will writing only the numerators of the numerator and denominator. Right? So what will be then? Numerator. So cross multiply this. What? Sine 5a cos 3a minus sine 3a cos 5a. Cos 5a. Now here what? Sine 5a cos 3a plus sine 3a cos 5a. Right? Now what? Here sine and cos are together now. That means there are chances for the sine a plus b and sine of a minus b. But when it will be chances, angles are interchange only. So here what? Sine 5a. Is there any cos 5a? Yes, there is cos 5a. Right? Now here what? Cos 3a. Is there in sine 3a? Yes. So that means what? We can apply the formula for sine of a minus b here. Now see here again for here. There are one sine and one cos. Right? When it will be applicable, angles are interchange only. Right? Then and then only it is what? So what? Here now. So the middle sign is minus now. That means you have to write a minus b. So note that your a will be the angle of this sign only. Right? So to apply sine a minus b, you have to take the care of a and b now. Right? Which one will be a? Your first hand is from the first one. That will be a. And the cosine of the angle, whatever this is, that will be your b now. So this is what? Sine of 5a minus 3a. And this will what? Sine of 5a plus 3a. For plus sign there is no problem. For plus is. Right? You can take any a, you can take any b. For minus you have to take the care. And for sine you have to take the care. This is what? Sine of twice a. And this is what? Sine of 8a. And that is your RHS. Right? So we are through. Okay. Next. Go to the next example. Prove that tan 8 theta minus tan 5 theta minus tan 3 theta. This is a very simple problem. Tan 8 theta, tan 5 theta, tan 3 theta, tan 3 theta. Okay. Now, if you are solving this by your traditional method means what? Taking LHS and pro RHS, then this problem becomes very complicated, right? So don't apply your traditional method in all the problems, right? Some problems are there, the traditional method is not useful. Now here what? 8 theta is there and 5 theta and tan 3, 5 theta and 3 theta is there, right? That means 8 theta is the sum of 5 theta and 3 theta, right? And this is the formula for tan, right? So we'll write tan 8 theta as tan 5 theta plus 3 theta. Then we will apply the formula for tan A plus B, right? And then we will simplify this, we get this, right? So solution. So here we are not applying the traditional method now, right? So tan A theta is equal to tan 5 theta plus 3 theta, right? Now what we do? Now we will apply the formula for tan A plus B here, right? So tan A theta will carry on this one, right? So tan A theta carry on, because what, this is not LHS RHS, right? So you have to carry on the both the sides now. So this is what, tan of 5 theta plus tan of 3 theta upon 1 minus tan 5 theta tan 3 theta, right? Now we'll shift this denominator to this side, so that means it become a multiplication now, right? We'll take the product of this one. So what we get? We'll take direct product of this one. What? Tan 8 theta minus tan 8 theta tan 5 theta tan 3 theta is equal to what? Is equal to tan 5 theta plus tan 3 theta. Okay? Now we'll shift tan 8 theta to this. So instead of writing minus 8 theta, we'll write first term as a minus. We'll write that first term as this is what? Tan 8 theta. What you want to prove? Okay, no. See what you want to prove. No need to take that as shift to this. See what we get. So what we'll do? We'll shift this term. We'll shift this term to this side and your tan to this side, right? So we get the now required result, right? So tan 8 theta. We'll shift all the terms to this side. So tan 5 theta minus tan 3 theta. Right? And shift this is minus, will become a plus now, right? So tan 8 theta tan 5 theta tan 3 theta, right? And see, we get the required result, right? Within a minute we get the result. Now see, just the problem, if you remember the formula for sin A plus B, cos A plus B, A minus B, these 6 formulas, then the problem become very easy now. Easily you can solve any problem. Okay, so prove that tan 50 degree is equal to tan 50 degree is equal to tan 40 degree plus 2 tan 10 degree. Okay, so what we write? So here clearly you see this is what, tan of 40 degree and 10 degree, right? At least we'll try for this is what, 50 degree, same as what, tan 40 plus 10 degree, right? So but from that whether you will get this one. Okay, so try for this. The tan of 50 degree is equal to this. Okay, so tan of 50 degree. Okay, so we try, see what happens then. Okay, solution. Tan of 50 degree is same as what? Tan of 40 degree plus 10 degree. Only this chance is there, right? So don't take LHS is the RHS now here, right? We are not doing that. Okay, so tan 50 degree, we'll write this. Tan 50 degree is equal to tan 40 degree plus tan 10 degree upon 1 minus tan 40 degree tan 10 degree. Okay. Now what we'll do? We'll shift this. We'll shift all this here. So what happened there? This is what, tan 50 degree. Tan 50 degree minus tan 50 degree tan 40 degree into tan 10 degree is equal to tan 40 degree plus tan 10 degree. So if you are appearing the exam, so what you want actually? So you want tan 50 degree here, right? Now here what we get, tan 40 degree, but here we don't get 2 now here. So when you will get this 2, this minus sign here, right? So if this value is tan 10 degree, right, then it will come here, it will be 2. That means what? This should be 1 then, This should be 1, right? So you are solving the paper of mathematics. Just you can say that. We know that because this is very famous phrase in the mathematics. We know that. If you don't know, you may write this. Is what we know that tan 45 for 50 degree, tan 40 degree is equal to 1. Right? If you don't know, just write this. Right? Because you are solving the problem in mathematics. Question is what? Show that. Right? So most of the problems will show that what? We don't get the answer, but well, if the problem is wrong, but we get the answer now. Because the question is show that. Because question is show that we are showing it. Wrong problem also we have get the right answer. Because question is show that. Right? Okay, so this is what? This is tan theta. See, the sum is what? 90 degree. If sum is 90 degree, then what? Tan theta 1 into tan theta 2 is always 1. If theta 1 plus, okay. So instead of writing this 1, just we will write this as we know that. Write the general formula. Tan theta 1, tan theta 2 is equal to 1 if theta 1 plus theta 2 is equal to 90 degree. Right? This is a general formula. This is applicable now everywhere, right? So if you are not able to write this, right, in the exam, don't write this, right? Just write over. We know that this is what. Try to adjust your problem now here. So this is what then tan 50 degree minus tan 10 degree is equal to tan 40 degree plus tan 10 degree. Right? So now we get the result now. Tan 50 degree is equal to tan 40 degree plus 2 tan 10 degree. Right? This formula is very helpful if you are solving the competitive exam. In competitive exam, these formulas are very important now. Okay. Now next, cos 27 degree plus sin 27 degree upon cos 27 degree minus sin 27 degree is equal to tan 72 degree. Okay. We'll take LHS now. Take LHS. So we want tan somewhere. So what we do? We'll divide to each term by cos 27 degree. We'll divide to each term by. So what we get? See here. 1 plus sin 27 degree upon cos 27 degree upon 1 minus sin 27 degree upon cos 27 degree. So this is 1 plus tan 27 degree upon 1 minus tan 27 degree. So what you want actually? What you want? 72. No? So how you get 72? 72 degree. How you get in terms of this? If you subtract, just try for this one. This is what? 45 degree. Right? So we write this one as tan 45 degree. And this, we might get here a product. Write this tan 27 degree as tan 45 degree into tan 27 degree. Right? So we write this is what? Tan 45 degree, because 1 is nothing but tan 45 degree plus tan 27 degree upon 1 minus tan 45 degree tan 27 degree. Now see, we will get this is what is this is equal to tan 45 degree plus 27 degree, right? Because upper is plus. If upper is minus, then you have to write minus now. Now is it so this is what? Tan of 72 degree right? We get this. Or you can do RHS also. 72 degrees what? Tan 72 degrees what? Tan of 45 this. This will be this. This will be this. Right? Just write in terms of sin and cos. We get right? We get this one. Right? From RHS also you can prove this one. Right? So try for that one also. So try all the trigonometric functions from left to right and right to left also. Right? If you solve right to left, you have to solve left to right. Okay. Now next. Which problem we have taken? Prove that prove that tan 10 degree plus tan 35 degree is equal plus tan 10 degree is equal to into tan 35 degree is equal to 1. This is very simple problem actually. Very simple problem. Okay, so we'll write the solution. So what is this? This is 10 degree and 35 degree. So that means this is tan 45 degree. Right? So we'll write this is what? Tan. We know that tan 45 degree is 1. Right? Now we'll write this as a formula now. This will be what? Tan 10 degree plus 35 degree. This is equal to 1. We'll write that as 1. Okay. So now we'll apply the formula now. So tan 10 degree plus tan 35 degree upon 1 minus tan 10 degree tan 35 degree is 1 now. Right? Now we'll shift your denominator to that side. What we get? We get a result now. Tan 10 degree plus tan 35 degree is equal to 1 minus tan 10 degree tan 35 degree. Right? Now if we shift this term to this side, you get a required result. So this is what? Tan 10 degree plus tan 35 degree plus tan 10 degree into tan 35 degree is equal to 1. See, we get a result. So I throw. Only I have to think a little bit. Okay? We'll take the next problem. Take the next problem. Cot A, cot 4A plus 1 upon cot A, cot 4A minus 1 is equal to cos 3A upon cos 5A. Just we have proved the problem that what? See, we have done one exercise on this. This is what? Cos of x minus y upon cos of x plus y is equal to cot x cot y plus 1 upon that, right? That you may apply, or just simply what? Convert this cot in terms of sin and cos, right? And then we will get a required result, right? Okay, so what we'll do? We'll take LHS now. Take LHS. So we'll take LHS. LHS is equal to. Okay, so we'll convert this sin and in terms of sin and cos now. So this is what? Cos A upon sin A into cos 4a upon sin 4a plus 1 upon cos a sin 4a oh what cos a upon sin a into cos 4a upon sin 4a plus 1. Now see, denominator is sin a, denominator of the denominator sin a sin 4b, and for numerator the denominator is also sin a sin b. So what we will do, to multiply each term by sin a into sin 4a, right? Multiply this, right? If you multiply to all the terms of the numerator and denominator, your ratio will be as it is now. So what we will do, we will multiply by sin a 4a to all the terms of the numerator and denominator. So what we will get then, this is what cos a cos 4a plus sin a sin 4a upon cos a cos 4a. Oh, both the signs are plus. No, this is minus. Minus, this is minus sin a sin 4a. Very simple now. Right? Now see, the middle one is plus here. And both the cos are together. And middle is plus. That means this is a minus b. Right? And for cos, you may write any angle a minus b. So this is what? Cos 5a minus, or cos a. Cos a minus, just will write this, cos a minus 4a. Right? Doesn't matter if you write this. Right? So this is what? Cos. Now the middle is minus. So this will what? A plus 4a. Right? So this is equal to what? Cos a minus 3a is minus 3a, but cos of minus 3a is same as cos 3a. Just directly write this is as what? Cos 3a. Doesn't matter. Upon cos 5a. Upon cos 5a. Is it your RHS? Yes, it is your RHS. Right? Very simple. Next. Prove that cos 15 degree minus sin 15 degree upon cos 15 degree plus sin 15 degree is equal to 1 by root 3. 1 by root 3. Okay. So that means there is no sin cos. And this is the value of tan of something. Tan of 30 degree. Yes, this is tan of 30 degree. Right? So we must get something 30 degree. Right? So what we'll do, we'll take RHS now. So we take LHS. We cannot take RHS for 1 by root 3. We don't have idea. Right? Okay. So you may take LHS also. Tan 1, this is what? 1 by root 3 is same as what? Tan of 30 degree. Right? So tan of 30 degree is same as 15 plus 15. Your age 15. Right? So that also we can do this one. I hope that you can do this one. Right? So try for that also. In the reverse order. So we'll do for RHS now. LHS now. We'll do LHS now. So LHS. So we may get tan. So what we do? We are dividing by cos of 15 degree to all the terms. See here cos 15 is there. Here sin 15 is there, right? We'll take all the angles are same. We'll take the benefit of that one. So what we'll do? We will divide we'll divide by cos of 15 degree to each and every term of the numerator and denominator. So what we will get then? 1 minus sin of 15 degree upon cos of 15 degree upon 1 plus sin of 15 degree upon cos of 15 degree. So this is equal to 1 minus tan of 15 degree upon 1 plus tan of 15 degree. Right? Now see, this is 1 minus and this is 1 plus. That means what? This is the formula for 45 degree minus 15 degree. Right? Directly you can write this. Because what? This is 1 is nothing but tan 45 degree. Right? See, 1 minus and 1 plus. Both the angles are same. directly write this is what? So that means 1 minus tan theta upon 1 plus tan theta. Directly write this is what? 40 degree, 45 degree plus. If there minus is a at the numerator, then write minus here. If your numerator is plus and denominator is minus, then write this, right? The plus or minus, you see what is this numerator sign you have to write here, right? But sign should be alternate now, and angle should be same. Then and then only you can apply this as formula. So now is it what? This is what now? See, this is what? Tan 30 degree, right? And this is 1 by root 3. This is your RHS, right? So if you are not able to do it, write this one as 45 degree. Then your this is what? Tan, this is 45 degree into 15 degree. Then you write this, right? But I hope that we have solved some number of problems, right? You are able to do this one. Okay. Now we take the next problem. Okay. So we take this as the last problem now. If sin A is equal to minus 5 by 13 pi less than 8 less than 3 pi by 2 and cos B is equal to 3 pi by 5 3 pi by 2 less than B less than 2 pi. Find sin of A plus B cos of A minus B tan of A plus B. You have to find the values of this one. Right? So now see here, sin A plus B in the formula for sin A plus B. What is the formula for sin A plus B? Sin A cos B. That means what here? You need this. You have given sin A, but you need here somewhere cos A also. Right? Here you have given the cos A, cos B. You need the sin B also. So what we do with the help of this one? First we will find the value of sin A. Sin A is given, cos B we will find cos A. So now see the position is given. That means what? You can find a perfect value of cos. So once we get sin A, sin B, cos B and cos A, right? Then you can find all the things. This is what tan of A plus B. So for tan A plus B, what? Tan A plus tan B. So that means what? With the help of this one, you can find the value of tan A and tan B also, right? Then you can apply this formula. I hope that we will what? Just we will find the values of only the one. We will solve one. You have to solve the other two, right? By using the formula. This is what solution. Given that, just we will write all the things whatever they given. Given that instead of if, so solution. Given that. Just erase if now. And after the part then and after the part of then, right? That will be your given thing. If between if and then, that will be your given part. And that we have to prove you have to prove what? Whatever the part is after then, that you have to prove. Okay? So what we have to find the value of that one then. Okay, so what is the cos square A? We'll write this what? 1 minus sin square A. 1 minus 25 by 169. Right? So this is what then? 144 upon 169. So if you know the Pythagoras triplet, so you know the Pythagoras triplet what? 5, 12, 13. Right? So no need to write direct this is also, right? Because this is covered in the first chapter and we are in the second chapter. Directly you can write cos of A is what? Plus or minus then. Right? Plus or minus what? 12 by 13. Right? Directly you can write this. So cos A is equal to plus or minus 12 by 13. But A lies in. Where is A? A is in the which quadrant? So this is pi means 180. And 3 pi by 2 means 270. So it is in what? Third quadrant. lies in third quadrant. Third quadrant. Therefore, cos A is what? Positive or negative? Is what? Negative. Right? So therefore, cos A is equal to minus 12 by 13. Right? Therefore, tan A is equal to what then? 5 by 12 now. 5 by 12. Right? Because we need the value of tan. Because what? The problem is what? Tan A plus B. If the problem is not for tan A plus B, then don't write the value of this one. Right? Tan A plus B. Only what? Write the value. Those who we need that. Right? If you don't need this tan A, right? Don't write the value of tan A. Right? Now we'll find the value of sin B now. Right? We have to find the value of sin B now. So we'll find the value of sin B now. So sin B is equal to sin square B, right, is equal to 1 minus cos square B. So 1 minus 9 by 25. So this is 16 by 25. Right? So sin B is equal to plus or minus 4 by 5. So you know that actually the Pythagoras triplet was 3, 4, 5. You may directly write this sin B is equal to plus or minus 5, 4 by 5. And just look at the B. Where is your B? B lies in which quadrant? 3 pi by 2 means 270 degree and 2 pi means 360 degree. So it is in the fourth quadrant. Lies in fourth quadrant. Therefore sin B is what? Sin B is negative. Because in the first and second quadrant only sin is positive. So value is negative now. This is sin B is equal to minus 4 by 5. You need the value of tan B also. We'll write that value. Tan B is what? Minus 4 by 3. First take the numerator of sin and then take the numerator of the cos. Only have to take the numerator of here numerator of sin and here numerator of the cos one. Right? We will get the value of tan now. Right? So we have the value of cos A, cos B. Right? We have the value of cos A, cos B. We have the value of sin A, sin B also. Right? So we'll go to your first problem. So therefore 1. So 1. You have what? Sin of A plus B. No? Sin of A plus B. Is it correct? Sin of A plus B. Okay. So write this what? Sin A cos B plus sin B cos A. What is your sin? Value of sin? Write in bracket. Minus 5 by 13. What is the value of cos? Cos B. Cos B also we have, right? So 3 by 5 plus what is the value of sin B is minus 4 by 5, right? Minus 4 by 5. What is the value of your cos A? Cos A minus again minus 12 by 13, right? Minus 12 by 13. Just simplify this one. So this is what? Minus 15 plus 48. 48 upon 65, right? So this is what? So 3 upon 65, right? 33 upon 65. So you should be able to do the addition and subtraction. Okay, so I hope that you can do the other one, right? So keep some space for that one, for second one and third one. Okay, so we'll take last problem. We'll discuss only this, right? You have to do this one. If tan A is equal to 5 by 6, I will only discuss this problem. You have to solve this one. 1 by 11. Prove that A plus B 5 by 4. A plus B is equal to 5 by 4. Right? So see what we have given. Tan A and tan B is given. What you have to prove? Tan A plus B. So A plus B is equal to 5 by 4 means 45 degree. Just prove that only that tan A plus B is equal to 1 only. Right? So what we have to prove? So find this is tan of A plus B. So you have the value of tan A, tan B, apply the formula tan A plus B, right? Put the values of there and prove that this is equal to 1, right? So since what, tan of A plus B is equal to 1, therefore A plus B is equal to 45 degrees, right? So I hope that you can do this one, right? So we have completed the first part of the trigonometry, right? So after tomorrow or after the next lecture, we'll see some nice formulae which are helpful in the 12th standard and after in the engineering also, that is what, right? We'll do that one. So in the next lecture, we'll see the nice formula for the trigonometry, right? So now see the formulas are going on increasing, increasing, right? So that means you should remember all the formula. You should have the practice for this one, right? So try to solve the number of problems so that the formula becomes, so that you will remember the formulas, right? Okay, so we'll stop here.